Okay, for 20 through 23, these are all factoring problems. At least they look like factoring problems, so once we dig into them, we'll see if they are. So here, we equal 0, so we're in standard form. So I'm going to go ahead and do 1 times 7 is 7. I need to figure out how to get to 8. And the only way to do that is 1 and 7. So we need to put it in factored form, x plus 1 and x plus 7. But since we have to solve it, we're going to also do x plus 1 equals 0 and x plus 7 equals 0. This gives me a negative 1 and a negative 7. Okay. In number 21, we also have a factoring problem. It doesn't say factoring, but you need to read the directions and understand what it's trying to ask you. Right down here, we found the x-intercepts. That's what we were doing. We were solving for x, finding x-intercepts, the roots. In 21, it says find the x-intercepts. That's the same thing we did here. It's just a different way of asking the question. So we're factoring, and we're solving. So we're making the y a 0, and we're going to go 1 times negative 12 is negative 12. And we're going to try to get to negative 7. So the only way to do that would be 3 and 4. But let's go ahead and change this 12 to a positive 12. I believe it's a typo. Alright, so now we would do negative 3 and negative 4. That would add to be negative 7. And if we multiply these, we get back to positive 12. Okay, so then we have x minus 3, x minus 4. We set each one equal to 0. And we get positive 3 and positive 4. Okay. In number 22, we have to do cross products. So we're going to say x times x plus 5 equals 2 times 7. Then we will distribute. Okay, it's very close to being in this form right here, but we need to have a 0 right here. So we're going to move the 14 to the other side, and if we do that, we make it negative. And then that gives us the equal 0. So to factor this, negative 14 to 5, we're going to use 2 and 7. So 7 minus 2 is a positive 5, and 7 times negative 2 is a negative 14. So we have x minus 2 and x plus 7 equals 0. So to solve, we're going to say x minus 2 equals 0, which is 2. And then x plus 7 equals 0, and that's negative 7. For number 23, we see that the number here is bigger than 1, so that's the bottoms up. So if I take 4 times negative 3, I get negative 12. And I'm trying to get to negative 5. So 12. I've got 1 times 12, 2 times 6, and 3 times 4. Well, none of these can get to negative 5. So this means I can't factor it. And we learned that if we can't factor a trinomial, then we use quadratic formula. So we're going to use this formula to go ahead and solve 23. So we've got A, B, and C. Okay, we've got to really watch our signs with our negatives here. And we're going to start plugging into the formula. So negative from right here, and then this negative from the problem, we know that 2 negatives become positive. So we're going to change that to a positive 5 right there. Okay. Then we have plus or minus the square root of B, again, is negative 5, squared, minus 4 times A times C. So A is 4, and C is negative 3. And this is all over 2 times A, and A is 4. So positive 5, so 5, plus or minus 2 times 4 is 8. That was easy to do. Okay, so negative 5 squared comes out to be positive 25. It is important that you get your signs right. Okay. Then negative 4 times positive 4 is negative 16. So I did this part right here. I got negative 16. Now I take negative 16 times negative 3, and that gives me a positive 48. So if I add these two together, I get 73, which can't break down. So my solution is x equals plus or minus the square root of 73 all over 8.